Alright, in this video we're going to discuss how to solve polynomial equations. Okay, so this is an example of a polynomial equation: 2x cubed plus 3x squared minus 14x minus 15 equals 0. So the idea is, it's like you're saying what are the possible values of x such that when we substitute that, the result is 0. So those are the the values of x. We call those roots, okay, or the solutions of the equations, okay, or roots of the equation, roots of the polynomial equation. To establish connection, let's go back to grade 9 when we solve quadratic equations. Suppose we have a quadratic equation: x squared plus 3x plus 2 equals 0, and we tend to factor this as x plus 2 times x plus 1 equals 0. Therefore, x equals -2 or -1. So there are two possible values of uh, x, the -2 and the -1. Since this is cubed, so it's like just like this. We are solving polynomial equations just like this. We are looking for the values of x, okay? But since this is cubed, we are expecting a maximum at most, okay? At most 3 roots. When you say at most 3 roots, pwedeng only one real root, only 2 real roots, or all roots are real roots. If it has 2 real roots, two real roots, therefore one is imaginary root. Okay. So the method is, how do we solve polynomial equations like cubic equations and quartic equations? Okay. So, but we have already idea of how to solve quadratic equation. Okay. So here we have, remember that if not factorable, you can use quadratic formula. So remember that we are just simply looking at the values of x, just like in the quadratic equation. Before we proceed to that, we want to this is actually connected to the factoring polynomials, because factoring polynomials plays a lot of roles in solving polynomials. Okay. So here, notice with those mark numbers. Okay, so in number 1, the polynomial expression is x raised to 4 minus 9x cubed plus 21 x squared plus x minus 30. And you notice that these are the factors, actually, the thing that we did in the previous lesson. Okay, we factored this polynomial into like this. You notice that the constant term 30 is actually, look at this, 5, 3, 2, and 1. If we're going to multiply this, we actually get 30. Okay, we actually get 30. So something like, there's an idea that this constant term, the possible factors of this, the factors of this constant term, because 5, 3, 2, and 1 are factors of 30. Okay, so the factors of the constant term are the possible roots or possible factors if it in factored form, or possible roots of this equation. Okay, so the same with the second one, you can see 42, and that is 2 times 3 times 7. Okay, so this one, guys, is what we call, this leads to the idea of rational root theorem. Okay, rational root theorem. Rational root theorem. Okay, so the rational root theorem, guys, only takes into account the constant term and the leading coefficient. Okay. So when you say constant term from in our example, 2x cubed plus 3x squared minus 14x minus 15, the constant term is 15. I'll just take it negative, positive 15. Okay, so this is 15, and our leading term, this is our leading constant term, this is our leading coefficient. Okay, the coefficient of the leading term, the one with the highest exponent. Okay, the one with the highest exponent. So the leading term is 2. Okay, so that's the first thing. So what the rational root theorem only, I'll just move it here. Okay, because we're going to solve that later on. Okay, so the rational root theorem gives us the possible roots. So gives the list of possible roots. And how do we do that? Factors of the constant term, which is 15, all over factors of the leading coefficient, which is 2. Okay, so how do the rational root theorem gives the list of possible roots? It takes into account the factors of the constant term divided by the factors of the leading coefficient. Just like what we did here, we know that 30 is just actually the product of 5, 3, 2, and 1. Okay, so factors of the constant term. Okay, so if we're going to do it one by one, we're going to get plus minus 15. Sorry, let's take a look. Plus minus 1, plus minus 3, those are plus minus 5, plus minus 15. So those are factors of 15. And then on the factors of 2, you have plus minus 1 and plus minus 2. Those are the factors of 2. Okay, then we are going to, from this, we're going to generate the possible roots. Okay, we're going to generate the possible roots. So the advantage of the rational root theorem is it gives us a limit of the list of possible roots, meaning we have a reference on which value is we are going to try using factor theorem. Okay, using factor theorem. Okay, unlike before that, without the knowledge of rational theorem, you're just going to guess, trial and error. But now we're going to do trial and error, but at least we have list of possible roots in which we can eliminate if necessary. So it gives us the list of possible roots. So these are the possible roots. Okay, these are the possible roots we have. If we're going to divide 1 and 1, we get 1 divide 1, that's 1. So the possible roots are, if we're going to divide 1 and 1, we get plus minus 1. 3 and 1, we'll get plus minus 3. 5 divided by 1, we get plus minus 5. 15 and 1, we'll get 15. Then we go back 1 and 2, we have plus minus 1 half. Then 2 and 2 will get 1, which is repeated already, so no need. Then we have 5 and 2 will get plus minus 5 all over 2. Then 15 and 2 will get plus 15 over 2. So these are the possible roots. We have 1, 2, 3, 4, 5, 6, 7 times 2 because both positive and negative. We have 14 possible roots. And by looking at this equation, we have only a maximum of 3. So from this 14, we are assured that if this one has real roots, andito yung tatlo na yun sa 14. At least we have that limit of what to try. We have that possible roots of what value to try using factor theorem. So now we are going to solve this using this root. So let's try with this one, positive and negative 1. So let's try x equals negative 1 using factor theorem. Or you can use synthetic division, because if it's a factor, you may not redo the synthetic division. You can use synthetic division or synthetic division. Meaning, guys, if x plus 1, this one is x plus 1, okay, x plus 1. If x plus 1 is a factor, therefore x equals negative 1 is the root. Okay, remember that. X plus 1 is the factor, x equals negative 1 is the root. And we are looking for the roots of these quadratic equation. Okay, so this our answers will be in this form. Okay, or we can use remainder theorem to try. Okay, let's use remainder theorem, because it says that factor theorem, we can do that. Factor theorem, remainder theorem and factor theorem are somewhat the same, just that. So if the remainder is 0, therefore this one is a root. Okay, so let's try. So we have, let p of x be that 2x cubed plus 3x squared minus 14x minus 15. Okay, so if that is 0, okay, if that is 0, then therefore that's the root. 3x squared negative 1 square minus 14 negative 1 minus 15. That is, I think that is not 15 plus 3x squared. Okay, so this one gives us negative 2. This one gives us positive 3. This one gives us positive 14. This one gives us negative 15. Oh, okay. This is negative 17 and this is positive 17. Therefore, this is 0. Since the result is 0, x equals negative 1 is one of our roots. Okay, one of the roots of this equation. Okay. So if not, let's try with another. So how do we do the other one? Let's going to divide using our strategy in factoring polynomials. Let's divide x plus 1 using synthetic division. This is to get the remaining depressed equation. We call it depressed equation. Okay. So we're expecting that the remainder is 0. So 2, negative 2, 1, negative 1, 15, positive 15. Yeah. So we have now a remaining equation of 2x 2x square plus x minus 15 equals 0. Okay, so this is our depressed equation. From cube, it becomes now quadratic. Okay, plus x minus 15 equals 0. So from that, we can now solve this using factorization. If you cannot solve this using factorization, you can solve it using the quadratic formula. Negative b plus minus b squared minus 4ac all over 2a. Okay, so this one gives us 2x, I think plus 3, because 2 times 3 is 6, and I want to have 5 here, because negative 5 and 3 is negative 15. Yeah, therefore the solutions are, this becomes x equals positive 5 over 2, and this one becomes x equals negative 3. So therefore the roots are so it's like saying that the factors, if we're going to go back to our idea in factoring polynomials, 2x cubed plus 3x squared minus 14x minus 15, this becomes, okay, this becomes, let me see if that's correct. Yeah, that's correct. this becomes, if we're going to factor this, remember that x plus 1 is a factor using our first test. Okay, then the other factors are 2x minus 5, x plus 3. Okay, these are the factors. The roots are x equals -1, 5/2, and -3. Okay, so these are our roots. These are the values of x that will satisfy our equation. Okay, so let's try with another example. So our equation is this one. So using rational root theorem, our possible roots are using rational root theorem, we have factors of our constant term 6 all over factors of our leading coefficient, which is 4. Therefore, you'll have plus minus 1, factors of 6, 1 is always a factor, then plus minus 2, plus minus 3, plus minus 6, then you have plus minus 1, plus minus 2, plus minus 4. Okay, listing that down, we'll have plus minus 1 for this and that, then this and that will give us plus minus 2, then this and that will give us plus minus 3, this and 1 will give us plus minus 6, then this and this will give us plus minus 1/2, then this 2 and 2 will give us 1, so that is already repeated here, so no need. 3 and 2 will give us plus minus 3/2. Then 6 and 2 will give us 3. So this already repeated here. So let's go back to 1 and 4. So we'll have plus minus 1/4. Then 2 and 4, that's 1/2. So it's already repeated. No need. Then 3 and 4, it's not yet repeated. Then 6 and 4 is 3/2. We're going to divide 6 and 4 here. That's 3/2, which is already repeated. So that's 1, 2, 3, 4, 5, 6, 7, 8 times 2. We have 16 possible roots, and we are only expecting what they call this 4 maximum real roots. Okay, so let's try one of this. So let's try x negative 2. Try x negative 2. Try x equals -2. So we'll have, let's go directly with synthetic division. In case it's a factor, we don't need to do the synthetic division. So we have that. To go back, we'll have 4, -4, -25, 1, 6. Then if that becomes 0, therefore -2 is one of our roots. So let's try 4. 4 times -2 is -8. This becomes -12, +24. Okay, 24, -1, -1, +2. 1 plus 2 is 3. 3 times -2 is negative. So -6 plus -6 is 0. Therefore, this one is one of our roots. Okay, so this becomes 4x cubed, because our given is raised to 4th, x raised to 4th. This one becomes 4x cubed minus 12x squared minus x plus 3 equals 0. And we can try again here. Okay, we can try again 3/4. Look at this, 3/4. Okay, so we can try again here. You can try doing rational truth theorem here, 3 and 4, to minimize the number of real roots. not anymore like this, but you can also choose from here. So by this one, 3 and 4, we can maybe choose 1, 2, 3, and 3/4. So let's try that one. Even 1/2, okay. So let's try x equals positive 3. So let's try x equals positive 3, not negative 3. So we'll use this already. So we have 4, negative 12, negative 1, 3. So if that becomes 0, therefore that becomes, this one is a factor. So we have 4, 12, so 0. 3 times 0 is 0, negative 1. Negative 1 times positive 3 is this becomes 0. Therefore, 3 and 2 are our roots. Okay? So, the remaining equation, this one, since this one is no more, this becomes 4x squared, okay, plus 0x minus 1 equals 0, or we can turn this into 4x squared minus 1 equals 0. Okay? Then we can factor this because this is quadratic. If it's not factorable, you can use quadratic equation, quadratic formula. So 2x minus 1, 2x plus 1 equals 0. So we have x equals 1/2 or x equals negative 1/2. Okay. Therefore, our roots are negative 2, positive 3, positive 1/2, negative 1/2. Okay. Therefore, the roots are negative 2, positive 3, positive 1/2, negative 1/2. Please write this in order from least to greatest. Okay, so that's it. That's solving polynomial equation using rational root theorem.